Hello everyone, I am uploading this video after a long gap. In this video, we are going to see the concept microservices. So without wasting any time, let's get started. First, we will understand what is microservices. So microservices are an architectural style where applications are developed as a collection of small, loosely coupled and independently deployable services. Okay, so as you are able to see, this is the monolith application and this is the microservices. In monolith, all things are on the same layer, due to which if one of the layer fails, then we are not able to figure out. Okay, but the microservices is an architecture which is separately developed. For example, these are the different services which are turned into microservices, and they do not means they are interconnected, but they are actually tightly coupled. So sorry, they are actually loosely coupled. Okay, then moving forward, what are the characteristics of microservices? It is small, focused on doing one thing well, independently deployable, organized around business capabilities, decentralized, then communication via lightweight protocols. Okay, if we compare this microservices application to the monolith is tightly coupled and it has a single code base. Okay, everything is present in a single code base. But microservices, they are means independently deployable and they are independent from each other. Okay, then what are the challenges of microservices? The complexity increases. Then we need to also means distributed system issues like their latency, load balancing, network reliability, and consistency. Then also managing transaction and consistency across services, handling communication protocols, monitoring and logging needs centralized monitoring and logging solutions. Okay, then why do we use microservices? We need to scale services independently based on demand. Okay, that's one of the reason. Then services can be written in different programming language suited for specific tasks. We might write some of the services in different programming language, but the code should not break. That's why we will place it in different microservices. Then small teams can work on different service simultaneously, reducing time to market. Then failure in one service doesn't bring down the entire system. If there's a single code base, if one system fails, the entire code base will come down. But in microservices, it is independent. Okay, so now we understood what is microservices. Now we will understand the e-commerce application, as I have developed the microservices for e-commerce. Okay, so this is the setting. Rather than understanding from here, we will understand from here. So I have created an order service and an inventory service. In this order service, I have created various controllers, DTOs required for it, along with entity, repository, and service layer. Okay, done. Same for the order service as well as the inventory service. When moving ahead, we need a service registration, that is the Eureka server. We will understand from this picture, as different service might also need to communicate between themselves. Okay, so that was the issue, that if there are more microservices, then the communication between them was a little bit challenging. That's why we came with an solution, that is the service registry. In the service registry, what we do, we create a discovery server where all the services will register themselves, and through that server they will talk to other services. Okay, so we are creating that over here. Why we need a service discovery? In microservice architecture, each microservice is a standalone application with specific business functionality. Since these microservices need to communicate with each other to function as a complete application. Okay, as I told, that they need to communicate between themselves, they need to know each other location. Okay, they need to know each other's location. But service discovery comes into play here. Maintaining a record of this services location means, actually the role of service discovery is actually maintain the location, network locations of that particular service. Okay, so for which we are using the Spring Cloud Eureka. Okay, the Spring Cloud Eureka has yeah, over here what's written over here. Eureka is a REST-based service which is primarily used for acquiring info about services that you would want to communicate with. Okay, so there are two things. One is the client, another is the server. Okay, so the microservices which will register on the uh, means discovery server, that discovery server is the server, and the microservices which are registering are the Eureka clients. Okay, see over here how Eureka works. Okay, how Eureka actually works. A service will register itself with the Eureka server upon startup. When the service will start, it will actually register on the discovery server. What we will do, we will actually try and run it over here in the services. We will first run the, okay, see now what I have done, I have created a discovery service over here which will act as a discovery server in its uh, see over here what we have done, we have actually enabled the Eureka server. This is the first thing we have done. Then in the resources, what we have done, we have allocated a certain port for it, that is the 8761, and then uh, register with Eureka we have done false, means that the discovery service which we have created, it should not register itself. So that's why we have done it false over here, and the registry is also false. Okay, then as I told that this is the server, but we need to make the microservices client. So in the inventory service over here in the target, sorry, and not in the target, in the main resources over here. Wait a second. I have actually, okay, over here, as you are able to see what I have done over here, I have means Eureka client, this marked this as a Eureka client, and the it will correspond to the default zone, that is this is the URL for it. Okay, I will show you the URL. First what we will do, same this line of code is added into the order service as well. Now what I will do, I will first run the discovery server application. Okay, wait a second, let the discovery server run first. Okay, wait a second, it's running. Okay, it has ran successfully. Now what I will do, I will actually run the inventory service, and then at that URL I will show you how it looks like. Wait a second, there's an issue over here. I will rerun it. It has ran on the 8761 port. Okay, it should be visible. We will actually try to run this code. Wait a second, what I will do, I will actually try to run this code then. Order service, try to run the order service application. Okay, the order service is running right now. Now what we will do, we will actually go over here. What's the issue over here? But as you're able to see in this log that discovery client, the order service is actually registration status 204. Okay, it has successfully registered itself. We might see over here also that the order service has registered its instance on the Eureka server. Okay, so the first thing which was actually that we ran the server, then we ran the client made an instance of it on the server. So now whenever it want to communicate, it will first direct its request to the server. From the server it will then contact to another microservice. Okay, so that's done. Then we will moving ahead. One thing we could do, we could also create a Spring Cloud API gateway. Okay, now we also need the discovery server, but we are now moving ahead with the Spring Cloud API gateway. Okay, we need an gateway where all the APIs will go, means for the communication of the APIs. So what is this? We will first understand. APIs are a common way of communication between applications. In case of microservice architecture, there will be a number of services and client. Client has to know the host name of all underlying applications to invoke them. To simplify this communication, we prefer a component between client and server to manage all API request called API gateway. We will actually manage all the requests from the client to server through the API gateway. Additionally, we can have other features which include security, routing, observability. Okay, so over here, Azure Spring Cloud API Gateway is a powerful, flexible solution for routing and proxying requests to downstream services in a microservice architecture. It handles several important tasks like routing, filtering, authentication, and load balancing. This is the user which will request the API. The API will go to the routing part, and from there it will be routed to the microservices. It has three things. Okay, we need to understand these three things first. Moving to the code part. Okay, what I have done, I have over here created an API gateway folder. It consists of, wait a second first. Okay, in the resources over here, what I have done, I have created a gateway. Okay, Spring Cloud gateway, and this is the route. As I told that we have two services, order service and inventory service. This is the order service. Okay, this is the URL. This is the LB, means load balancer. Then we have added this predicates over here, and also the strip prefix. We could also redirect this to a certain platform. Okay, then same for the inventory service. Over here we have created a inventory service, added the predicates, and we could actually filter this as well. Okay, but if I want to show you the communication between them, how I could show you, let me first understand it. Mm. Give me a minute, I will actually show you how we could. So we will do one thing. We will first see what sort of things are there in the PPT. Okay. We'll first try to understand the three functionalities which are provided in the API gateway. So first is the route. Okay, the route it has in it we specify the destination that we want a particular request to route to. It comprises of destination, URI, a condition that has to satisfy, or in terms of technical terms. Okay, Second is the predicate. This is literally a condition to match, kind of if condition. If request has something, then path or request header contains this. Okay, we'll try to first see the actual. mm, Over here we have actually passed the URI. This URI means where we want our API to point. So it is currently pointing to the order service. The order service has the name, application name as order service, so that as per that we have specified over here. Then in the predicates we are actually passing the path, which where it will be directed, and these are the filters. Okay, we will understand as we talked about that predicate. In predicate it is the conditioning. If this condition matches, then as per that we will route to means get request and other. In the filter there are instance of Spring Framework web filter. This is where you can apply your magic of modifying request or response. There are quite a lot of out of box web filter. Okay, these are the filter which we could use. We could add the request header, response header, then redirect to this website, or strip the prefix. Okay, strip the prefix of the path. That could be done with the help of filter. We will learn about filter in upcoming classes as well. Then this there comes the open Feign microservice communication. Spring Cloud OpenFA is a declarative HTTP client library for building RESTful microservices. It integrates seamless with Spring Cloud and simplifies the development. Okay, it abstracts away much of the boilerplate code typically associated with making HTTP requests, making your code base cleaner and more maintainable. So this is the dependency for it. After that, it actually helps. For example, there is communication going on between two different microservices. So for that communication it actually helps a lot. For example, what I will do, I will actually show you the code base. Okay, for example, a user is creating an order. Then after the order is created, the stock, from the stock the means the amount should be subtracted and total price should be returned. Okay, so for that we will first see the order service. Okay. Mm, this is the inventory one. In over here we have order this. Okay, here we will create order. So this is the create order means API. Okay, when we will hit this API, what will happen? We will go to the order service. In the order service, what we will do, we are actually here we have logged it. Then the next thing is we are going to, as see, we have created an order, we have passed the items which we have selected. Okay, now we want to check in the inventory whether that items are available, and if available what is the total cost. Calculates its total cost and then subtract it. Okay, so what we are doing, we are going to the inventory open Feign client. Okay, which we have created. We have created it in the order service. Okay, we went over there. Then from here we will be mapped to inventory service. Okay, we will now go to the inventory service application. Then over here there is a method reduce stocks in the inventory. Now we will be actually mapped product slash reduce stock. Then from here now we will be sent redirected to this means over here product controller. As in the product controller we have reduce stocks, we will be sent over here. Okay, from here see what happened. We went to the inventory service application. In the inventory service we have a controller which is been mapped over here. Then we went to the product controller. This is the controller. From here we will actually go to the product service. Then in the product service now we have this method over here. What we are doing, we have set the total price to be 0. From the list which we got of items, we are actually finding the ID and quantity of that particular product, then checking in the repository whether that exists. and if we have the quantity that much which we have means booked. Okay, if yes, then we will set the stock, means we will update the stock, and we will also get the total price with it. So we have done the same for every product, and we are then returning the total price over here. So the total price will be returned over here, then over here to the controller. From the controller it will be returned over here double, and from here we will actually get the response. Okay, so that's the example of open fin client. It is actually helpful between the communication of two microservices. Then we move forward to the resilience 4j. Okay, in the resilience 4j is a lightweight standalone library designed for implementing resilience pattern. So it actually implements retry, rate limiter, and circuit breaker. Okay, for the retry means if the logic fails, then we want to retry for certain number of times. Okay, so that could be set. Give me a minute. In the e-commerce, where were we actually? In the order service. Okay, we could set the retry over here with the help of annotation. We could implement a fallback. Okay, the fallback could be wrote over here. For example, I have written over here a fallback. Okay, so that's only. And over in the resources application dot properties, we add, wait a second, in the currently I'm in the inventory. Below I will find the, in the resources application dot properties, over here, sorry, YML. In the YML we specify, see, the resilience and the retry. Okay, the retry should be max attempt should be this much, and the wait duration should be 100 millisecond. Okay, we could also use the config or instance. Config means it is used to means globally give that config, means default. The default will be this much. Okay, then the instance of the inventory retry, which we have named to the retry, for it we are giving it over here, means we are just, it is the repeating. So to avoid the repetition of the code, we are using the config. Then same for the rate limiter means how much request should be allowed in that particular time period. For example, if we see over here, controls the rate of request to a service by limiting the number of calls allowed during a specific time period. It will limit the number of calls. Okay, number of calls, for which also above the method we will use the @rate limiter annotation, and in the YML we will provide the needful information. Same for the circuit breaker as well. Circuit breaker is a new concept, means if everything is running fine, then it will be in the closed state. Okay, but if something is failing again and again, then its state will be changed to open state, and after a certain period of time it will let the application retry till a certain number of times, and if in that period it response, means then it will move to the half open state. Okay, if it success, then again to the closed state, or if it fails, then it will again go to the open state. Okay, so circuit breaker pattern helps stop an app for constantly trying something that's likely to fail. If something is failing likely again and again, in that case we are actually using the circuit breaker over there. For it also we use the @circuit breaker annotation, and these are the properties which we add in it. The sliding window size means 10 requests will be allowed. See, if 50% of this request fail, then it will be its state would be changed. Then the duration for waiting, we specify all that details, yeah, for the circuit breaker. So that's all the concept which I have learned in the microservice. I will also make another video on the advanced concept which I am currently covering in the microservice. So for that, stay tuned. Thank you.